Hello everyone, in this video I'm going to discuss the example for limits and then sketch the graph. For the function we have the fx which is equals to 3x over the square root of x squared minus 9. Determine the vertical and the horizontal asymptote, hence sketch the graph. So step number 1, going to find with the domain. So refers to the function we have the 3x over the square root of, we have the x squared minus 9. So we can express the situation which is fx is equals to 3x over square root of x minus 3, x plus with the 3. So focus on this part, we have the all real number. Focus on this part, we have the situation x minus 3, x plus with the 3, and then greater than 0. So notice that we have the positive, and then we have the split and assume always positive. So illustrate the situation, we have the negative 3 and 3. So empty circle. Empty circle. So here we have the negative. So positive, negative, and positive. So our domain will be something like this. So negative infinity until negative 3, where negative 3 is not included. From the 3 until infinity, where the 3 is not included as well. So here we have the domain. Second step, we have the x-intercept and also the y-intercept. So when y is equals to 0, kindly substitute the situation where we have 0 is equals to 3x over the square root of x squared minus 9. So 3x is equals to 0, x is equals to 0. So if it refers to the situation in here, so we have the number line, we have the negative 3 and the 3. So there is a graph for these two sides, but no graph in the middle. So refers to the intersection, we have the 0, 0. So actually where's the location of 0, 0? It's in the middle, where there is no graph, or we can say undefined for this part. So meaning that no solution for the x-intercept and also the y-intercept. Continue, number 3. We're going to find the vertical asymptote. So limit when x approaching negative 3 from the left for the function, where we have the 3x over the square root of x minus 3, x plus with the 3. And repeat the same process. We have the limit when x approaching the negative 3 from the right. We have the limit when x approaching 3 from the left. Limit when x approaching 3 from the right. So kindly substitute the function. So kindly refers to the number line. In here we have the negative 3, here we have the 3. So based on the situation in here we have negative 3.0001, and then we have negative 2.9999. Next we have 2.999, and then 3.0001. So next what we have to do is to substitute this number into this part. Where obvious we will have the negative sign, and then for this part we will have a negative. Same goes to this part, we have the negative. So refers to the situation and we have negative infinity, meaning that decreasing without bound as the x approaching negative 3 from the left. Next, focus on this part. So actually the number does not exist for negative 2.99999 due to the domain. So we can say it does not exist when x approaching negative 3 from the right. Same goes to this part, does not exist as well because of the domain. Next, focus on this number. If we substitute and we will have a positive. So same goes to this part, we have positive. So we have the positive infinity, meaning that when x approaching 3 from the right, the graph increasing without bound. So from here, vertical asymptote are x is equals to negative 3, x is equals to 3. Next, number 4 is to find the horizontal asymptote, where we have limit when x approaching negative infinity. For the function, we have the 3x over the square root of x squared minus 9. So what we can do is to focus on the situation So factor the square root of x squared. So here we have the limit when x approaching negative infinity. So we have x bracket 3 over, we have the square root of x squared, square root of 1 minus 9 over x squared. So based on the definition in here, the modulus of x actually is the square root of x squared. And we have the definition x and negative x with the domain x greater or equals to 0, x less than 0. So we have the situation on the number line. So for this case, as the x approaching negative infinity, so meaning that towards the left, and we have to make use of the negative x. So limit when x approaching the negative infinity. So here we have x multiplied with the 3 over, we have the negative x multiplied with the square root of 1 minus 9x squared. So we can simplify. So limit when x approaching negative infinity, we have the negative 3 over the square root of 1 minus 9 over x squared. So based on the situation, and we have the negative 3 as x approaching negative infinity. Repeat the same process. Limit when x approaching positive infinity, we have the situation x multiplied with the 3 over, we have the square root of x squared, we have 1 minus 9 over x squared. Based on this case, so we have x approaching positive infinity means that towards the right. So we are going to make use of the x. So from here, limit when x approaching positive infinity. So we have the x multiplied with the 3 over, we have the x multiplied with the square root of 1 minus 9 over x squared. So we have limit when x approaching positive infinity, we have 3 over the square root of 1 minus 9 over x squared. And we have the value of y, which is equals to 3. So the horizontal asymptote, y is equals to negative 3, y is equals to 3. So next we're going to sketch the graph. So kindly reverse number 1, we have the domain where we have the negative 3, negative 1, negative 2, negative 3. We have 1, 2, and 3. So we have the asymptote, negative 3. So here we have x is equals to 3, x is equals to. So here we have x is equals to negative 3, x is equals to 3. So number 2, there's no interception. Number 3, we have the vertical asymptote stated in here. So refers to this part. X approaching negative 3 from the left. So we have the negative infinity. Here we have does not exist. Here we have does not exist. Here we have x approaching 3 from the right. So the value of y is approaching positive infinity. So meaning that going up in here. Refers to the horizontal asymptote. So we have y equals to negative 3 and the 3. So let's say here we have 1, 2, and 3. Negative 1, negative 2, and negative 3. So y is equals to negative 3. Y is equals to 3. So as x approaching negative infinity, approaching negative 3. So meaning that here we have two situations. So when x approaching positive infinity, we have the 3. So here will be our situation. By referring to the calculator, if we substitute the x, which is negative infinity, for example, negative 100, into the function, so we will obtain a value which is less than or below the negative 3. So we have to erase this part. So if we substitute x equals to 100, and we will obtain a value more than 3. So we have to erase this part. So the graph will be something like this. Same goes to this part. So that is the function fx, where we have 3x over the square root of x squared minus 9. For the function, we have.
If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.